Okay, so now let's talk about significant figures. And essentially, when we talk about significant figures, we talk about all of the certain digits in a measured number and the first estimated or uncertain digit in a measured number. And really what it comes down to, for the most part, are zeros. Because, and what we're going to do now is go over the rules for figuring out how many significant figures are in a measured number. Because the first rule essentially is that a number is a significant figure if it is A, not a zero. So that means in a measured number, all the ones, all the twos, all the threes, all the fours, so forth and so on, all the nines are significant. No matter where they are in the measured number, they are significant. So in the example 4.5 grams, both the 4 and the 5 are significant. So that measured number would have two significant figures. Okay, so now let's talk about the zeros. Letter B, a zero between two non-zero digits are always significant. And that's whether the zero is to the left of the decimal point or to the right of the decimal point. If the zero falls between two non-zero digits, those zeros are significant. So in the number 205 meters, the 2 and the 5 are significant because not a zero. And then the 0 in between the 2 and the 5 is significant because it's between two non-zero digits. So 205 meters would have three significant figures. Letter C, a zero at the end of a whole number if followed by a decimal point. Now, in a measured number, whether the decimal point is written or not is important. And we'll get into that, the specifics of the difference in a few moments. But if you have a whole number and there's a decimal point there, if you have zeros after the last non-zero digit, those zeros are going to be significant. So for example, if you have 50 decimal point liters, not only is the 5 significant, but the 0 is significant as well. And therefore you would have two significant figures. Just jumping ahead a little bit, if you had 50 liters without the decimal point, now you would only have one significant figure because the 5 would still be significant, not a 0, but now the 0 would not be significant because it's not followed by a decimal point. Okay. Letter D, zeros after the last non-zero digit and, it's a combination here, to the right of the decimal point are significant. So the 2 and the 3, they would be significant because they're not a 0. And these two zeros here after the 3 would be significant because they are after the last non-zero digit and they are to the right of the decimal point. As we'll talk about in a moment, the 3 zeros before the 2 would not be significant. So this measured number here would have 4 significant figures. Okay. Now let's take a look at zeros when they're not significant. Because really, as we, a number, not a 0 is always significant. So again, when does it come down to? It just comes down to the zeros. So a number is not significant. It is if it is basically letter A, zeros at the beginning of a decimal number. Zeros at the beginning of a decimal number. So for example, 0.0004 seconds, all the zeros before the 4 would not be significant. Another way of saying letter A is that basically all the zeros to the left of the first non-zero digit are not significant. So here, Only the 4 would be significant, not a 0, and therefore you'd have one significant figure. Letter B, used as a placeholder in a large number without a decimal point. Basically, what that's saying is that you have zeros after the last non-zero digit of a whole number without the decimal point. So here, where you have 850,000 meters, only the 8 and the 5 would be significant because the 4 zeros in this whole number, there's no decimal point at the end. So the 4 zeros here would not be significant. On the other hand, if I wrote 850,000 decimal point meters, now all those zeros after the 5 would become significant. So I would have 6 significant figures. So what's the difference? Remember, significant figures are all the certain digits and the first estimated or uncertain digit. So without the decimal point, the first estimated or uncertain digit is the 5. So is it really 850,000? Or is it 840,000? Or is it 860,000? We're estimating in that place. But when the decimal point is there, now we're estimating in the ones place. So is it 850,000? Or is it 850,001? Or is it actually 849,999? So whether the decimal point is there or not as written in the measured number is important because it tells you where the estimation was made. All right. So one of the things you'll have to do with the homework is not only be able to tell how many significant figures the measured number is going to have, but be able to identify all of the rules that you use to come up with the correct number of significant figures. Okay. Just to quickly go over the other types of numbers that you come across, or what are known as exact numbers. Now, exact numbers are obtained one of two ways. First off, by counting. Essentially, counting is an exact science. You know, if you have 8 cookies that are laid out on a table, you should be able to get as many people as you want to come in, and they should all be able to agree that there are 8 cookies. And the way they would get that is basically by going 1, 2, 3, 4, 5, 6, 7, 8. For the most part, counting is an exact science, and therefore 8 cookies would be an exact number. The other way we come up with exact numbers is by definition. And in mathematics, the way we talk about definition is with the equal sign. When you have the equal sign, essentially, you have definition. So for example, and I'll use the one on the bottom here, there is exactly 1 kilogram. 1 kilogram is exactly equal to 1,000 grams. The 1 and the 1,000 there are exact because the equal sign there talks about definition. Now, essentially, in laboratory and clinical settings and such, we come across a heck of a lot more measured numbers than we do exact numbers. I mean, we do a little bit of counting, and the definition part is more for theoretical type purposes and stuff like that. So the majority of the numbers that we come across are really your measured numbers.